Hey, this is Russ Anderson. Today we're going to take a look at a special kind of stereoscopic shot where all the trackable features are far from the camera. Now, normally with a stereoscopic shot, even if the camera's on a tripod and moving around, you can still recover depth information as long as trackable features are relatively close to the camera pair. But if everything is far away from the cameras, then it's pretty much back to what you get with a tripod shot when there's only one camera. So that's the kind of shot we're going to look at here. And you can't tell what the interocular distance is. You can't, that's something that you need to generate. You can generate it arbitrarily. You may need to recover what the divergence changes have been during the shot. So let's take a look at what happens when we start out solving this shot. Since it's an all-far tripod sort of shot, we select a different solving mode to start out with. We let the solver run. And the first thing that we're going to do is go through and clean up the trackers. And I'm just going to show for illustration a couple of different ways to do that. First way is just to observe here that a bunch of these trackers are at least a little bit close to the camera, and there's a lot of repeating texture there. So I'm just going to take those particular ones out. Another method that I'm always a great fan of is explained in the Working in the Dark tutorial, which is to turn off the image display and looking for trackers that are doing something funny. So here's one of them there. When you see it doing something strange, we just go and delete it. Another approach is to use the Cleanup Trackers dialog. And the Cleanup Trackers dialog is really intended for monocular cameras, but we can still use it here. Instead of letting the Cleanup Trackers do the fixing directly, we'll just have it select the trackers that need to be deleted, close the dialog, and then hit the delete key to take them out. And finally, we can use the graph editor. We'll sort things by error. We'll select all the trackers. And let's just rescale. So we can either run through things from the top, looking for the worst trackers, or we can just look for particularly large peaks. I'll set the isolate mode, and here's something that we can either repair or just delete the tracker outright, your choice. So that's a bunch of different ways to look for tracking problems and clean them up. Well, once we've done that, let's just go and update our solve. And after deleting those trackers, we're down to a bit over 1 pixel of error. And if we look in the top view here, you'll see that both cameras are present and they're moving around independently, but they're located at the same spot. And we need to create an interocular distance. And we're going to do that using the stereogeometry panel. At first, I'm going to just show something else so you know what to do if you need to. That's if I want to change the dominance, it's going to ask you if you want to flip the direction of the link. So normally the links, when the right camera is dominant, the trackers on the left camera have the links to the right. If the left camera is going to be dominant, then we want to have the links on the right camera trackers going back to the left. So it will switch them automatically and quickly for you. So that's just what to do if you suddenly find out that you need to do it the other way around. But back to our interocular distance. If we need to set up an interocular distance, we're just going to create a known value. And I'm just setting up a single fixed value. But we could go and generate an animated interocular distance if we needed to as well at this point. And there's basically nothing in the images to argue otherwise. So if we go and update the solve again, you'll see now we have the two cameras located at different locations. And you can see that the dominant camera is standing still and the secondary camera is moving appropriately. And they're separated by the interocular distance that we set up. So having done that, we're now in a position, that we can export to our particular animation package and bring something up close to the cameras and still have it be located properly to that interocular distance. One other thing to point out, because these kind of all far shots are basically tripod sorts of shots, all the trackers are far away. They're distances, they're directions rather than a point that has a distance to it. So there's no 3D information about the setup of the scene. So we're going to have to, one way or another, finesse that to be able to locate things in the 3D environment. And, in a shot like this, there are parallel lines in the image that you can use the single line alignment features, or perhaps you can just cook up some XYZ values for points on the field and use that to locate things. But one way or another, this is very much a tripod sort of shot, and just as a result of what was shot, there just isn't the 3D information available that there normally would be. One last detail, you'll see that once we've set up the interocular distance, we see pairs of trackers here, and that's both the left and the right versions, and they're kind of split apart due to the interocular distance, so we can just tell it that we want to see only the one of them as needed, and I've already got that for the perspective view. So here's some of the details of how to handle this kind of shot. Hope that helps. Take care.